Hello everyone. Today we present INE2002 term project, statistical analysis of used car price. We use it at dataset of 1000 car with 12 variable and applied 11 statistical methods in R. I am Furkan Rıza Söylemez and I will cover data collection, frequency distribution and data description. Let's go to slide 2. This dataset is random sample of 1000 used car listings. The target population is a global used car market. It has 12 variables, 7 numerical and 4 categorical. As you see in the table 1, the average price is about $59,217 with a standard deviation of $33,545. Price range from the $3,028 to $119,612, and model years from 2005 to 2024. The 10 brands are almost equally represented, about 100 cars each. 48.4% of cars are automatic and 51.6% manual. Now let's look at the frequency distribution. Now the frequency distribution using Strager's formula, we found 11 classes with the weight of the $11,000 each. As you can see the figure 1, prices are spread almost evenly across all range with no clear peak uninformed distribution. Figure 4 shows brands and similarly balanced, and from give about 50% of cars are priced below $56,807. Now I will hand over to Mustafa, who will talk about central tendency, variation, and confidence interval.
Here we calculated central tendency, variation, and position. The mean price is $59,217 and the median is $56,807. Close values. So the distribution is slightly right skewed but almost symmetric. Skewness is 0.0848, almost no skew. Kurtosis is 1.83, below 3, so our distribution is flatter than normal. Our coefficient of variation is 56.6%, which is quite high, and the EQR is $57,058. As you can see in the box plot in figure 6, price distributions look very similar across brands, and using the 2K rule, we found no outliers. Now, let's test if our data follows a normal distribution. Here we tested if price follows a normal distribution. As you can see in figure 7, the normal curve does not match the real histogram shape. And in the Q plot in figure 8, points move away from the line at the ends. Both the Shaper-Wilk and Lilfors test gave very small p-values, so both reject normality. Our Pearson skewness coefficient is 0.2156, a very small right skew, almost symmetric, but not normal. Figure 9 shows the central limit theorem as sample size grows from n equals 5 to n equals 50. Sample means become closer to normal around $59,217. Now, confidence intervals and sample size. Using the t-distribution, the 95% confidence interval for the mean price is $57,135 to $61,298, with a margin error of about $2,082. For the automatic transmission ratio, the 95% confidence interval about 45.3% to 51.5%, with a point estimate of 48.4%. To estimate the mean with an plus minus $2,000, we would need at least 1,081 observations, and for a proportion with a plus minus 0.05, at least 385. Now, I will hand over to Dilara for hypothesis testing and group comparisons.
Here we tested a hypothesis with 3 methods. Hypothesis null test mean price equals $65,000. Alternative hypothesis test not equal at alpha equals 0.05 two-tailed. Our t statistic is minus 5.45 beyond the critical value of plus or minus 1.96. P-value is almost zero and 95%, $57,135 to $61,298, does not include $65,000. All three methods reject hypothesis null test. So our mean price of $59,270 is significantly lower than $65,000. We also run required paired t-test in part 7.4, but engine size and horsepower have different units, so it was only for demonstration. Now let's compare different groups. Here we compare groups as figure 10 shows price distribution for automatic and manual cars look very similar. And a t-test confirmed no significant differences. P equals 0.801, diesel versus petrol also showed no differences. P equals 0.7235. One interesting result, only 32.4% of cars have their first owner, significantly different from 50%. So null hypothesis testing is rejected there. The hybrid versus petrol automatic ratio showed no differences. P equal 0.1734 and variance were equal between automatic and manual. Now correlation and regression analysis. Here we did correlation and regression analysis. As figure 11's heat map shows, all correlations are close to zero. The highest is only 0.0764 mAh. Price versus kilometers gave R equals 0.0476, P equals 0.132, so null hypothesis test is not rejected. In the scatters plot in the figure 12, the regression line is almost flat with R-square equals 0.0023. Even more, multiple regression model with the predictors only got R-square equals 0.011, with a prediction interval including a negative price of minus $4,570. Now I will hand over to Mehmet Emin for chi-square test, ANOVA non-parametric test, and our final results.
We used four chi-square tests as figure 14's mosaic plot shows. Full type and transmissions type look independent. Brands are uniformly distributed and owner types does not change by full type. The only significant result was the normality test. Prices are not normally distributed, matching par 5. Now our UNOVA results. As figure 15's 2K HST plot shows, all intervals cross zero, no significant price difference between and brand pair. Eta squared is only 0.0096. So brand explains about 1% of variance. Full type also showed no difference. In figure 16's interactions plot lines for brand and transmissions cross, but the two-way UNOVA found neither effect significant. Now the non-parametric test used when normality fails. Since normality failed, we use non-parametric test, the sign test, and Wilcoxon signed rank test, but showed the median price is significantly lower than $65,000, matching part 7. All other tests, rank sum, Kruskal Wallis, Sperman, and the rounds test, gave the same conclusion as their parametric versions, with no significant differences by transmissions, brand, or kilometers. Now let's summarize our results. Finally, our result, the key finding is that unlike the right scaled prices we had expected in real markets, our price variable is almost uniformly distributed. Because of this, nearly all 11 methods found no significant relationships between price and brand, full type transmission, kilometers, or power, and our regression model had are squared values near zero. This is likely because the dataset was artificially created with a balanced uniform price distribution. Our main limitations are the artificial price structure and the lack of condition, accident, and location data. Future studies with realistically connected features could give more meaningful results. This is the end of our presentation. Thank you for listening.